लिख तो कर रही हूँ मैं। Okay, I hope you can hear me now. Let's get started. Yeah, I think we are on now. So, hi, my name is Manoranjan Padhy. I work for the developer relations team at Google, and I work on the Launchpad program here in Google, focusing on machine learning and AI startups. So today I have like a 120-minute slot with all of you, which is primarily divided into two parts. One is where I'm going to talk about what is machine learning, what's TensorFlow, and how you can do it, and how you can get started with it. After that, I'll be showing you a code lab. It's called TensorFlow for Poets, using something called as Quick Labs. So let's get started with it. But before I talk about TensorFlow, it's very important for us to know what is machine learning. So, but before machine learning as well, it's very important for us to know what's human learning. So let's go back to our childhood when we were kids and we used to look at objects. And the way we used to recognize them was with the help of shapes and color, as well as how it would taste it. So I remember when I was a kid, the first thing I would try to do is try to eat it, to get an idea what that thing is. And that is when my parents would uh, either stop me from eating it if it's something that's not edible, and would allow me to eat it if it's something that's edible. So there were various factors with the help of which I identified things. Here on the screen, you can see there are two objects. Now, if I look at it, or you look at it, you can clearly tell that this is an apple and the other one is an orange. But the kid can't do that. Or when you are learning it, you can't do that. First, you look at the object. The first thing that your parents will tell you, okay, hey, this is round in shape. And the second thing that they'll tell you is this is red in shape. And then when you touch or when you hold an apple, you would feel that the texture is smooth. Okay. And when you try to eat it, there are two possibilities. Either the apple is like it will taste somewhat sweetish, or it would taste somewhat sour in taste, basically. And combining all this information, you would come to something that's a name, or in the machine learning term, we call it label. So this means that that thing is an apple. And when I do the same exercise with this other fruit that's there on the screen, if I hold it, it has a texture that is rough. If I look at the color, my parents would have told me, hey, it's an orange because it's orange color. And the taste of an orange is usually sweet, or the taste of an orange is usually sour. Sorry. Now, my parents again will pass me a label or will tell me that this fruit is identified as orange. So, this is how my learning capabilities were built up. And this is how the learning capabilities in humans are built up. Now, let's go back to what is machine learning. So, one thing I like about machine learning is it can have a lot of definitions. One of them that I usually do in my sessions is machine learning is giving a computer the ability to act without being explicitly programmed. Okay. Now, this means I'm going to train my machine in, let's say, if it's an object recognition, then I'm going to train my machine in two things: to recognize whether it's a football or to recognize whether it's not a football. Okay. So this is a combined decision of various things like yes, no. And that is when that is how I gradually reach to a decision that whether it's a football or whether it's not a football, or in this case, if it's an apple or if it's not an apple. Now, let's look back at core machine learning concepts. What is artificial intelligence? People think that artificial intelligence and ML are the same thing, as well as deep learning are the same thing, but they're very, very different things. Consider artificial intelligence as a football ground, okay, or the perimeter of the football ground. Machine learning can be considered as the stands where people sit in that football ground. And deep learning can be considered as basically the grass area where people are, or the ground actually, where people or the players are playing football. So you can see that ML is a subset of AI and DL is a subset of ML. But again, there could be different things. AI generally, if I talk about the types, it's like a rule based systems. Machine learning is regression, SVM, neural networks, KNN, and then there are deep learning. Or to summarize, like if I also tell you that artificial intelligence existed since long back. So because it says it's a rule based engine. If I talk about let me consider an example. A car manufacturing unit, yes. In a car manufacturing unit, there are robots. These robots are programmed to do very one specific task. So there's a rule that is defined for them, and they need to follow it. Like there's no they don't have to be very smart and correct themselves in this particular case. Like if a robot is supposed to do welding in car parts, the robot is going to do welding and nothing else. Now, few core machine learning terms that I would like you to remember is model. What's a model? A model is a box of algorithm that, given some inputs, try to produce desirable outputs. That is like a prediction. Consider a system which is telling you whether the particular fruit that you see is an apple or is not an apple. So that algorithm which allows the system to tell it's an apple or not is basically a model. Label, the desired output or the prediction. So here in this particular case, label is actually the name given to whatever output that you are getting. For example, in the first slide we saw that labeled is the name of the fruit is basically a label. Feature is a known input. For example, before all the characteristics of a fruit are fit into a system, we extract features. So these features and characteristics are the same thing. Like texture of an orange is the feature or is the characteristics. What is that feature or characteristics? It's basically is having a rough surface. That can be one of things. Feature is a known input. Example is a pair of inputs and outputs, if applicable. Now, categories of machine learning. There are four categories of machine learning: supervised, unsupervised, semi supervised, and reinforcement. So, when I talk about supervised, is basically machine needs to be told what the correct label is for a particular input. Unsupervised is machine identifies similar examples in the data set without knowing the labels. Semi supervised is uh, only some examples have labels. Guide and reinforcement is basically guide machine which decision to take in order to maximize rewards. Now when I go further into it right now, you will be able to see these things under various examples. So yeah, let's talk about supervised learning. Supervised learning is something when a machine needs to be told what the correct label is for a particular set of features. Like if I want to, if consider this, as you can see on the screen, this is a dispenser machine which is going to dispense like either wafers, chocolates, when you insert coins into it. So here you can see currency, coin currency, basically for 5 cents, 10 cents, 20 cents, $1 and 50 cents, and it is in the Singapore dollar denomination. So when you enter this thing in it, it basically gives you an idea. Hello. Yeah, sorry, I think there was some glitch and I kept on speaking and the volume was disconnected. Okay, I think you are able to hear me again right now. So I was talking about supervised learning. Machine needs to be told what the correct label is for a particular set of feature. So consider this case like you are going to a vending machine, or or yeah, you're going to a vending machine and you want to get some wafers or biscuits or chocolates. So there are basically specifically mentioned like you need to insert a coin and you need to mention which coin that you have inserted. Okay, so based upon that coin that is inserted, the machine should be smart enough, or the vending machine should be smart enough to give you out a chocolate or to give you out a wafer in this particular case. So that is what it's called supervised learning. Now, supervised learning is how the machine is trying to find out. One is the shape of the coin, and the second thing can be the weight of the coin. So here you can see there's a graph which is doing plotting based upon weight and size. So here you can see like there are five type of different colors: blue, gray, green, yellow, and red. So what does that mean is blue color ones could be the 5 cents coin, because you can see the radius of that coin is smaller, and because the radius is smaller, I believe of course the weight will be also different from the other coins. But then it's variable. It's not like if I have entered the weight of a 5 cent coin as 1 gram, and if the coin is 0.98 gram, then it should actually reject it instead of taking it, saying that the currency is not valid. Then the machine does not make sense. But the machine should also take a consideration of plus and minus, because as you know, with usage of coins, or when you start using coins, the weight usually of a particular coin decreases, or because of rough and wear and tear thing. So that's called supervised learning. Okay. Unsupervised learning is when machine identifies similar examples in the dataset without knowing the labels. Yeah. So here again, let's go back to the vending machine example where I'm entering the coins in the machine that I have. But the system inside is not telling the machine what is the label. Like it's not telling it's a 5 cent coin, it's a 10-cent coin. Instead, the machine is able to identify on its own, basically. So here, if you look, there are again five different clusters of pointers that is put on a weight on size axis on a scale. Here you can see, yeah, what it's happening is again these are divided into different subcategories. So the bottom one, the machine thing, if it is falling in that criteria, this means that it could be a 5 cent coin. If it's falling in the criteria that's after it, could be a 10-cent coin, and vice versa. Now let's come to semi-supervised learning. Machine is told correct labeled for some examples. Like if I'm training my model, and then for certain examples, I'm telling the machine that this is the label of that particular object. Like I am telling the machine like this could be an apple, but I'm not giving the labels for all the apples, only for some of the apples. Reinforcement learning. Machine is guided to make decisions in order to maximize rewards. So what is the classical example of it? I hope, or you might be knowing this game of X and 0. So machine is guided in every step to maximize the reward that is being achieved. So here you can see the machine is clearly winning the game, or the user who is playing is clearly winning the game. So what does that mean is machine is able to learn, or machine is guided with every step that is happening. It's the same game of X and 0. And one famous example of this is the AlphaGo match that the Google DeepMind challenge took place between Lee Sedol and AlphaGo, where in the beginning, Lee Sedol basically won most all the matches, but after that, the machine learned from Lee Sedol and it used the guided decision to maximize rewards and finally won the match itself. Now let's talk about how this whole overflow was working. Here we talked about basically four major types of machine learning. Training, we had app training, and then prediction. These are the two types in the workflow. Now, in training, when I'm training my model, the first thing that I'm going to do is, here you can say the apple is written here. Okay. But so what I'm doing is I am first step is a feature extractor. I'm extracting all the features from that particular fruit that I have. Now all the extracted features are given to the ML algorithm. Okay. Then after that, I am also passing a label to this ML algorithm. Now the training that I have done with the help of that, I am doing a prediction for it. In prediction, I'm going to extract features from this apple and those features and then put into a classifier model. Now this classifier model, with the knowledge that it has gained from the previous learning that I have done, is successfully able to predict whether this is an apple or what type of fruit this is. Now look at activity visualization of model. Here what we are going to do is we are going to do 4 or 5 steps, or we are going to visualize how actually machine learning can be done. So the first step is define, second step is get data, third step is explore, fourth step is choose techniques, fifth step is get tools, sixth step is model, seventh step is deploy, and the eighth step is monitor. By the way, if you have any questions or something, I am also trying to monitor the live chat from my phone. I will try to answer if you have any questions. So feel free to put it in the comment section, basically. Now, let's talk about the first thing, or the step one, is that you need to do is you need to define the objectives. That is, what insights do you want to get from your data? Do you have labels for the, okay, now you, once you have decided that what are the insights you have want to get from your data, second thing you need to ask is, do you have labels for the data, or you know what that data is? Now after you have decided do you have labels, there are two things that are going to happen. One is yes, you have labels, and second is no, that you have labels, because answer to a question here needs to be in binary, that's yes or no. So if your answer is yes, we will go to step 2, that is getting the data. But if your answer is no, then you need to check with yourself, can you create the labels? Now, if I say yes, I can create the labels, I'll go to step 2, that is get the data. But if I say no, I'm going to ask myself one more question. Is unsupervised ML useful for you? If I say yes again, then I'll go to step 2. If I say no, then I need to stop. This means that I can't proceed with building a ML model in this very particular case. Now, I'm going forward to step 2 because I have found out that I'm able to create labels in because I did not had labels earlier. Now, here I need to do is keep calm and form hypothesis. Like I need to find out what are the features, okay, and what are the labels of those particular objects. Let's say I'm building a classifier for a fruit, trying to classify whether it's an apple or whether it's not an apple in this particular case. Okay. So first thing I'll do is, like in the case of apples that I did was I extracted features from it. Okay. So what does feature extraction means is finding out what is the texture, what is the color, what type of surface does it have. After that, step 3 I need to do is explore the data, that is quality, distribution, and outliers. These are the three important things that I'm going to do and explore the data. What is the quality of the data? What type of distribution that is have? Is it an even or uneven distribution? And what are the outliers do I have? Like here you can see different type of charts where I've plotted my data. One is a 3D bar chart, one is a band chart, one's a stacked bar chart, bubble chart, line chart, cylinder chart, and like all sort of things. Step 4 I need to do is this sorry. Step 4 I need to do is decide whether it's supervised or unsupervised, because I need to choose the technique here. If it's supervised, then I'll do some things like decision tree, random forest, neural network. If it's an unsupervised, I'll do a k-mean, hierarchical clustering, or anomaly detection. Now, what are the tools that I can use? If I have an unsupervised and semi-supervised learning, it's usually expander or graph mining tools. If I have a data analysis and interpretable model, then it's usually LPH, Glassbox, pre-recognition, or RankLab. If I'm going to use general ML platforms, then it's TensorFlow, Ape, Disbelief. If it's a hyperparameter optimization, it's mostly Vizier. Now I have reached the step number 6, that is model. So what are the four important things? The model is prepare, train, validate, tune, and test. Now here, what I'm talking about is I'll prepare my data, I'll train my model, I need to validate my model. After I validated it, I need to test it. Then I'll go to step 7, that is deploy. So this is the most important part. Here you are basically deploying your models to the cloud host that you prefer, like Google Cloud Platform in this particular case. And after that, you just keep on monitoring and maintaining whether the model is performing correctly or not. And if there's an issue, then how you can sort out that issue basically. Okay, let's come back to talk about something about fitment. Okay, or how you can fit models. Now I'll do an assumption called of two things. One is T store, second is an ABNC fast food corporation. So here I'm considering an example of a tea store where there's a famous pan country tea store, dedicated store serving 101 type of tea since last 50 years. And then there's a fast food corporation, which is a 5-year-old restaurant chain which is quickly catching up and has a huge variety of dishes on menu and serves two or three type of two or three type of tea. Now, because I'm a person who loves having tea, uh, I usually prefer going to the tea store. But here in this example, I'll do a quick Google search of which are the tea stores near me. When I do that, I get this result that there's a tea store called as AB&C Fast Food Corporation, or actually, if I tell you it's a fast food corporation which also sells tea, that's at a distance of 3 minutes, and the tea store is located at a distance of 5 minutes, basically. Now here I need to decide that which way I'm going to follow, and which way I'm not going to follow in this particular case. Here, because the tea store is only 5 minutes away, I don't mind actually walking those particular 5 minutes and reaching the tea store hereby. But let's say there is a twist in this particular use case. Like there's a bridge that I need to cross, and this bridge is on top of a river, and this bridge basically opens up whenever a ship has to pass through it. Okay. So what will happen is instead of spending 5 minutes as of earlier, I'm going to spend 15 minutes right now. So instead of going to the tea store, I'll obviously prefer to go to the AB&C Fast Food Corporation. So the few things that we are trying to tell here is ML is like good parenting and garbage in and garbage out, that you can see here in this particular case. Second thing is don't blindly trust examples, like teaching ML to be cautious. You can see in this drawing where this toy train is floating in the air, which is a bad example of reality. Second is the baby distrust, like when baby starts learning something super quickly. So how far will you go for T store here in this particular case? Now I have plotted a graph based on the scale of user happiness and distance. Uh, Here I have plotted from 1 kilometer to 10 kilometers, and I have plotted different T store here in this particular case. So what will happen is I have already done a search of where I'm going to go. Now, if I decide that I'll go outside my house and follow or drive straight on the road, okay, and will stop on the tea store that's only on the road, then this means my model is too rigid, that is, it's underfit. Now, because this is underfit, I might not reach to my destination forever because I'll keep on driving, and again and again and again on the same path. Now, second, what I need to do here is fitment of our data. Now, how I denote a line is y is equal to wx plus b or y is equal to mx plus c. Here in this case, when I'm talking about y, so it is the value we are trying to predict. X1 is the input data. W1 and B are the values we are trying to fit or learn from the data subscript, while be useful for more problems with more dimensions. But it's just not fitting data. We often use linear models as models, but ML is more than just fitting the points we have. We need a line that generalizes well to new, previously unseen data. That is, there should be a line which is able to pass through all the points uh, to make this, or to which actually denotes a linear model in this particular case. Now, a good learning is always like this, like the graph that you are looking at. It's not a straight line that's too rigid, but it's a curve that passes through the nearest point and makes this sort of shape, basically. Or that is how I can reach product excellence. Now, how can you get started with machine learning? There are three steps with the help of which one can get started with machine learning. One, you just create a Google Cloud account. You get the credits, like there are some initial credits that are available, and you use those credits to use APIs like Vision API, Speech API, NLP, Natural Language Processing API, Translation API. Step number two is you are still using Google Cloud, but you are storing your model or you are storing your data in cloud storage. You are running BigQuery and you are using ML engine that's develop, model, and test. And the last one is TensorFlow on your own hardware. So here, what is happening is when you are traversing from step A to step C, you will get more modularity. That is that you will be do or you will be able to make your model the way you want it, but the effort required will be higher. Okay. Now, because the effort required is higher, so what does that mean is maybe writing the code. Second, training the model by yourself on your own hardware. And when you are trying to train the model on your own hardware, you need to make sure that you have the sufficient hardware based upon the model that you are trying to train. If it's a resource heavy task, then you need to check, do you have a GPU or you do not have a GPU? If you do not have a GPU, how capable is your CPU to do this stuff? Now let's go to TensorFlow. So what is TensorFlow? TensorFlow is a multi-dimensional array of a graph of operations. That is two different ones joined together. TensorFlow today is like, it's amazing 2 years. So this is the status as of 1st January 2018. You can see the increase in the GitHub stars in TensorFlow when it from since its initial release. Now, these are the community contributions that are coming from TensorFlow right now. There are 30,000 plus commits already. There are 6,900 plus pull requests. There are 1,400 plus contributors from all across the world. I'll pause here for 5 seconds so you can look at the screen from where the contributors are coming. Okay, moving forward. So we talk about three things: openness, transparency, and participation. TensorFlow is now the #1 repository in machine learning category on GitHub. You can run it across different hardwares, CPUs, GPUs, cloud TPUs, that's cloud tensor processing units, embedded devices like Raspberry Pi, iOS, and Android. Cloud TPUs is Google's own custom hardware where you can run your ML models, and yeah, it's faster than GPU as well. TensorFlow runs in many languages. And this year, we also have started to support Swift and JavaScript. JavaScript, when I talk about, it's the TensorFlow JS that you would have been hearing or you would have heard, or I'm not sure if you're hearing for the first time as well. So with TensorFlow JS, you can author models directly in your browser. Second, import pre-trained models for inference. Third, retrain imported models again in your browser itself. Now, TensorFlow Lite performance is getting much better. That is 3x inference speed on MobileNet and Inception v3, and quantization techniques store and calculate numbers in more compact format. So TensorFlow Lite adds quantization that uses an 8-bit fixed point representation. You can see on the graph here. Hardware support is continuing to expand. Like we can see AMD, Nvidia, Qualcomm, Intel, Google Zone hardware, and many more. So these are the few benchmarks that we are talking about. TensorFlow with Intel MKL DNN integration. That's Intel multi-node CPU scaling or training ResNet 50. It's plotted on two axes, basically speed up of X and number of nodes. So there's a 3x inference speed up on Broadwell and Skylake. There's 94% efficiency when training with 64 nodes cluster. TensorFlow with NVIDIA TensorRT integration. That's 8x inference speedups on 1 Tesla V100 with Tensor cores. Mixed precision training with Tensor cores. These are again benchmarks that we have plotted. Second, we are talking about TensorFlow scaling efficiency. So we are able to get 90% scaling efficiency with real data and 95% scaling efficiency with synthetic data. So you can see there's not a major difference between the scaling efficiency of real data as well as synthetic data. TensorFlow provides great tools like TensorBoard here that again you can see in this particular case. Ways to use TensorFlow is one is, and we are using it for NMT, that is neural machine translation. So earlier you would have seen or heard what quality of translation you would get if you are using TensorFlow, if when we were not using NMT basically. So earlier it was like a human layer, a face-based MT. That's a face-based machine translation, where every word is compared after the translation and a sentence is being formed. Here, the point or the problem was like you need to write hundreds and hundreds of lines of code, and still you would have seen like a couple of years ago what kind of translation quality it had. But after we have added the NMT layer or the neural machine translation layer, the things have changed a lot. Like you can definitely see that we have able to reduce errors by 55 to 85%. Okay. And if you see the translation quality, without the NMT, it was somewhere around 5. Now it's somewhere around 5.75 or something. Uh, English to French is again similar. English to Chinese was like somewhere around 4. Now it's somewhere near 5. And similarly, it applies to Spanish to English, French to English, and Chinese to English. Now, here, second technique is show and tell. Here you can see a sentence that is formed by the machine based on the objects that are here. So, what are the things we are talking about? It's a blue and a yellow train traveling down train tracks. Now, the second one is a person on a beach flying a kite. These are again, it's like a machine is being shown this image and is able to do the captioning. Number of Google directories containing model description file is production used in many areas: search, Gmail, translate, maps, Android, photos, speech, YouTube, play, and many more. Research used for hundreds of projects and papers. TensorFlow case studies, TensorFlow at Google, like we are using it at a lot of places in terms of mobile development, deployment, where you can do translation. A lot of other products like YouTube, Play Store, Android, Google Cloud, Drive, messaging, music, the way you listen to music, or recommendations in music as well as YouTube. There's a revolution in machine learning. With the help of machine learning, we were able to identify like there are two systems that you are seeing here is Kepler 90i. Kepler 90i and Kepler 80g. Here we were able to identify a planet that was not discovered earlier in the Kepler 90 system with the help of using machine learning. So it was very similar to the way the Earth is. It's just that Earth takes around 365 days to make a complete rotation around Sun, while the planet in Kepler 90i is just taking 14 days. We were able to identify it using ML. Second is identifying diabetic retinopathy or ability to identify disease even before it's striking the owner. or even before, sorry, it's striking the person. Now here you can, in case you can see the image of retina, and here it's a machine image of blood pressure prediction focused on blood values, blood vessels. Now here you can see a Euro control center where they are using ML in the air traffic control systems. What are the next steps? If you want to, like, what I talked about is very, very basic steps in machine learning. But if you want to do more, or if you want to know more about machine learning, if you are interested in other courses, you can try out tutorials and code at tensorflow.org. Then intro to deep learning with TensorFlow using this Udacity class, Stanford CS23 I1N. Then Udacity's machine learning nano degree. And if you're totally new to ML, you can try out ML recipes by Josh Gordon. Also, Google has a new machine learning course called as a machine learning crash course. You can go to google.ai. In google.ai, you can go to the education section, and from that you can try out the machine learning course. It's a 14 hours machine learning course for beginners, and it's free of cost. It has a lot of hands-on example. So yeah, please feel free to try it out. So that's all. If you have any questions, you can directly ask me right now, or I mean, you can tweet to me at underscore Manoranjan P on Twitter. Okay, so let's go forward to code labs. Here we are going to do this quite simple, an introductory level code lab called as TensorFlow for Poets. So you need to sign into google-run.quicklab.com, or if you're doing it right now, I'll give you like 2 minutes basically to do this process. So just try to find out what is the TensorFlow for Poets code lab in this thing, and we'll start back in like 3 minutes. Okay, I believe now that you would have opened this code lab already. If you haven't, like, you can take 1 more minute before we start. It usually says 1 hour to finish this course, but that's the maximum time that you will need to do, because it's just an introductory level course. You will not need this much time. Okay, let's get started with the code lab now. I hope all of you have opened it. So, again, I'll just repeat. You have to go to google-run.quicklab.com. There you will find TensorFlow for poets, or you can just go here, do a quick Google search for TensorFlow for poets. It's also available on codelabs.developers.google.com. Okay, let's try out one thing. If you're not able to open Code Labs or Quick Labs, or if you don't have access to Quick Labs, just do a quick Google search for TensorFlow for Poets in Google and go to the first link that you will see, which directs you to TensorFlow for Poets on codelabs.developers.google.com slash codelabs hyphen TensorFlow, sorry, slash TensorFlow hyphen for hyphen poets. So when you click on this link, you will ideally come to this code lab. So what we are trying to do is, I'll give you an introduction here in this particular case. In this code lab, you will learn how to run TensorFlow on a single machine and will train a symbol classifier to classify images of flowers. So here you can see the classifier is given as an output that the probability of this image being a daisy is 0.99. Probability of being a sunflower is 0.005. Uh, Probability of being a dandelion is 0.00252. Probability of it being a rose is 0.00049. Probability of it being a tulip is 0.00032. So it means that this image is a daisy. And if you sum up all these things, you'll usually get a point number one. So in ML, the confidence is always measured between 0 and 1, and you'll need to set a threshold value. So as I mentioned, to try out the machine learning crash course, when you try out that course, you will learn various things like threshold value, how do you set a threshold value for different models. That will give you a much better understanding. So here we will be using transfer learning, which means we are starting with a model that has been already trained on another problem. Okay, we will then retain it on a similar problem. That is, deep learning from scratch can take days, but transfer learning can be done in a shorter order. So it's like, if you are going to use ML on the same task, then you can use transfer learning. So what you will learn is how to use Python and TensorFlow to train an image classifier, how to classify images with your trained classifier, and what you will need here is a basic understanding of Linux commands. Now, here in this particular case, because it's not like because I'm using a Chromebook, I can't install all this stuff in my laptop. But if you are using a Linux machine, or if you're using a Mac or a Windows machine, you can do that. So here in this particular case, I'll go back to Quick Labs. So Quick Labs is actually a Google Cloud self-paced labs. So it's the same thing that you were seeing in this particular screen, but it will be happening on Google Cloud. So I'll click on Start Lab first thing. Okay, I've already clicked on it. So the lab is just getting kicked on. Now, because that's happening in Google Cloud, and as I mentioned, you do not need a Google Cloud account in this particular case. I'll open an incognito window. Go to cloud.google.com. If you do it in the same window, it will ideally take it your Google account itself. I'll go back to the same screen again because I need the username. I'll copy the username. Sorry. Then I'm going to copy my password. Again, this username and password will be provided by Quick Labs itself to you. Click on next. Accept. Done. After that, I'll go to console. I have selected my country of residence, India. That's because I'm based out of India right now. Sorry. I agree to the terms and services conditions for the using the API. Then I'm going to just select the project. Do I have any project? Yes, I have this project. So I'm going to select this particular project. Open it. Okay, set. I'm all set in my project that I should be in. Now I'll go back to the instructions. So I've already done this setup. I've already used this username password to open the Quick Lab. Now, what it's asking me is the Cloud Shell. I need to open a Google Cloud Shell. So once they're connected to the Cloud Shell, you'll see that you're already authenticated and the project is set to your project ID. So let's try doing that if we are there on the same screen. But we have manually done that already. So, but we will still try it out using the console. I've just clicked on console. I'm waiting for my console to be configured. It says my active account is the QuickLab account that I've just created. So I'm good to go. Now I need to create a development machine in the compute engine. So what I need to do is in the Google Cloud Console, I need to go to compute engine. In that compute engine, I'll go to VM instances. And in VM instances, I'm going to click on the button create. And I'll need to specifically select all these things like the name, dev host. Machine type is N1 standard 2 instance 2 version CPUs, 2V CPUs, 2 virtual CPUs. Boot disk, click change, then select Ubuntu 16 TLS, then select. And identity and API access allow full access to all cloud APIs. Go here, compute engine, VM instances. Okay, let's remove this. Create an instance. Okay. Before we do that, also let's see what was the region. Let's confirm the region. Okay, it's not basically specifying a region to me. So I can select a region that's you can select a region that's close to you, or you can go with the pre-populated region itself. It just specifies the machine type that's N1 standard 2 instance. Hit on click create. Now you can see my instance is being created. In the meantime, let's go and see what are the next instructions that I need to follow. Second, it's asking me to install TensorFlow in the SSH window. We need to run the following to install Python package manager. Okay, now I have done that already. So you might experience some lag depending upon the region that you are selecting. Now I'll need to install TensorFlow following the same commands. Now I'm going to open Python. Now I'm in Python 2.7.12. Now it's asking me to import TensorFlow STF. So dot TensorFlow STF. Yeah. So now I'm successfully able to import TensorFlow STF. This means that uh, I have successfully installed TF. So when you type this command import TensorFlow STF, if you get an error, this means there is some problem that is caused in installation of TensorFlow. So please go back to the commands and see what is the issue that we have that has happened. Here, what we are trying to do is we will just see how we can write a hello TensorFlow, a hello world constant hello world. Now I need to print what is stored in there. Oops. So you can ignore this warning. Now I need to run this command to print. So yeah, it's printing my hello world. So this means TensorFlow is working perfectly fine. Now let's exit the Python interactive shell and we are going to clone the Git repository now. Now all the code in this lab in this Git repository, use the following command to clone this repository. So if you have done Git earlier, then this is the same command that you would be using on your laptops, on your desktop. It's git clone. Or if you're pushing it to GitHub, it's usually git push. It's cloning it. Now let's change directory to the folder that we have cloned. Okay, done thing. Now I'm already in that photo. Now I'm going to download the training images. Before you start any training, you'll need a set of images to teach the model about the new classes you want to recognize. Now, we have created an archive of Creative Commons licensed flower photos to use initially. So download the photos. That's around 218 MBs by using the following commands. So let's go back. It's downloading these images, you can see. And it's done. 218 MBs. Now I have done an ls to flower underscore photos. Inside that, there are sorry, five folders basically. One of filled with daisy photos, one filled with dandelion photos, one with roses, sunflowers, and tulips. Now we need to move the flower images directly into tf underscore file. So what we are going to do is move, that's mv flower underscore photos to tf underscore files. Perfect. I'm done here. Now, what I'm going to do is retraining the network in this particular case. So here you can see is it's not very difficult of a codelab to do. There's a model that already existed. We are not writing our own models. We are just using transfer learning. You just need to know the Ubuntu commands or the Linux commands to be able to run this codelab. Now, the retrain script can retrain either Inception v3 model or a mobile net. In this lab, you will use a mobile net. The principal difference is that Inception v3 is optimized for accuracy, while mobile nets are optimized to be small and efficient at the cost of some accuracy. Inception v3 has a first choice accuracy of 78% on ImageNet, but the model is 85 MB and requires many times more processing than even the largest mobile net configuration, which achieves 70.5% accuracy with just a 19 MB download. So the following configurations are available, like input image resolution, this, and then the relative size of the model as a fraction of the largest mobile net. Like you can try out all sort of things. Now, after with the recommended settings, it typically takes only a couple of minutes to retrain on a laptop. For this lab, you will use the highest settings. So pass the settings inside Linux shell variables with the following command. Because I'm doing everything on the cloud, so I'll go with the highest settings. But yeah, you can feel free to use different settings. That is, you can use the input size resolution of 128 pixels, 160, 192, or 224. In this particular case, we are using 224. Now let's do one thing. Let's see. We also want to see the visualization of data. So TensorBoard allows you to get a visualization of data or the model that you are going to train or you are training. So TensorBoard is a monitoring and inspection tool included with TensorFlow. You will use it to monitor the training progress. In order for your VM to get to TensorBoard, you will need to create a firewall rule. So in the console, click on dev host, and then we will be clicking on create firewall rule. And now we need to set up a firewall using name TensorBoard targets all instances in this network, source IP range of 0.0.0.0/0, and protocol and port sets type in TCP colon 6006. So I'll go back to my uh, link again. Okay. I hope you are able to see. I'll just show you again what we are going to do. Sorry. So here we are going to create a firewall for the TensorBoard on port 06006. So in the console, click on dev host, that is that you would have created. Now scroll down and under network interfaces, click on default under the network heading and click on firewall rules on the left, then create firewall. So I'll try to show you. Let me try to do this thing, maybe minimize it. Okay. So here I've already clicked on dev host. I'll just show you again. You'll need to click on dev host. Once you click on dev host, you'll need to scroll down to network interfaces. In network interfaces, click on default. Now, once you have clicked on default, you need to click on create firewall rule here. Then you'll need to create a firewall rule. The name of our firewall rule is TensorBoard. I'm not going to give a def this thing. Targets all instances in this network. Source IP ranges, that's 0.0.0.0/0. Protocol and ports, type in TCP colon 6006. TCP colon, because we want the port 6006, that's the particular case. Now click on create rule. So my rule is being created. Okay, perfect. I'm done. So what are the next steps that I'll need to do is I need to start the TensorBoard. That is, I'll come back here, click again, TensorBoard, and click here. Okay, so it says that when you open this, you will ideally get an error because dev host colon 6006 is nothing, but you'll need to replace this URL will now how you get to TensorBoard. So you need to replace dev host with you need to replace dev host with an external IP address for your VM and refresh the browser. So I'll need to come here back. Perfect. Now my tensor board is there are no dashboards active for the current data. So what you need to do is when you how do you go to your I'll just show you quickly. You'll need to go to VM instances. In VM instances, you need to see the external IP here. So when you click on VM instances, you will find something like this. You click on dev host again. Once you click on dev host, you will see your external IP. So in my case, my external IP is 104.198.71.82 colon 6006. 6006 is the port that I just created. Perfect. My tensor board is already. I'll again minimize it to the same scale I was in earlier. Now, let's investigate the retraining script. The retrain script is part of the TensorFlow repo. You will not see anything here until and unless until it's retrained. So, uh, the retrain script is part of the TensorFlow repo, but it is not installed as part of the pip package. So, for simplicity, I've included in the lab repository. You can run the script using the Python command. Take a minute to skim its help. You might need the press enter again to return to the command line in SHH window. So yeah, sorry. My bad. Perfect. So I need to start my training now. So what's happening is this particular script downloads the pre-trained model, adds a new final layer, and trains that layer on flower photos you have downloaded to the lab. That's the 200 MB size photos that we have downloaded. And ImageNet does not include any of this flower species you are training on. So this kind of information that's make it possible for ImageNet to differentiate among 1000 classes are useful for distinguishing other information as input to the final classification layer that distinguishes your flower classes. Like, uh, yeah, we'll just wait for it to download. I'm waiting for my training to be done. Yeah, it usually takes some time. Perfect, we are done. So now you can see that I'm able to see the tensor board now because the training is completed. So you can see the graph training accuracy, cross entropy, then the mobile net that we are working on right now. You can also see the histogram here, by the way. Okay, now coming back to our problem. But everything is fine. I need to, classify whether this particular image is a daisy or not. That's what I'm trying to do, right? That's my end goal. So again, I'll just run this command like using the retrained underscore graph.pb. That's my model file. And this is inside the daisies folder. This is the image name. Trying to find out what my model thinks is that thing is. Yay. So this is the output that I'm getting here in this particular case. That is daisy score 0.99734 of that flower being. Now let me try something that's you know okay, I think I'm stuck somewhere. I'll try to identify other image. So this is the image that we are trying to identify and see what's the accuracy of the identification. So it says that 0.99%. Uh, just a second. It's a tulip point 0.00007. It's a rose. So well, it did not compare really that well to the first one, because in the first case, while my model was successfully able to identify it's a daisy, in the second case, it was not able to identify it was a rose in this particular case. Now, second thing you can do is trying out other parameters if you have time, basically. Then you can also try out your own categories if you are going to download these images. If you are not going to use quick lab, let's say in this particular case, well, let me just close this console. Okay, close TensorBoard, sign out from this project, sign out. Yep, the VM will be automatically terminated when I end the code lab, so don't worry. Yeah, so you can also do this thing like these are the same steps that are here of downloading the training images, then retraining the network, training and TensorBoard. TensorBoard is again optional. Then using the retrained model. This is the same thing that we tried to do with roses and daisies. Now trying out other hyperparameters, training your own categories, and what are the next steps that you'll need to try out, basically. Yeah. So this is the code lab all about. And this is the introduction to machine learning talk we talk all about. It was mostly about what is machine learning, what are the different types of machine learning, what are the things you can do in TensorFlow. After that, where TensorFlow is being used globally. Then what are the use cases in medicine, then in air traffic control, how we are using machine learning inside Google, some comparison of real world data and synthetic data on how we saw like there was only a 5% difference of accuracy in real and synthetic, like 90 to 95%. It's like good in any ways. But I would definitely suggest you like this talk and this code lab is not intended to make you an expert in ML, or doing this will not make you an expert to ML. You should try out some real world courses out there, like the one that I mentioned to you. I can, in fact, just do a quick search and show it to you. I'll just do Google search of machine learning, or I'll go to google.ai. Sorry. Now, once I'm here, I'm going to go on to the education section. Inside that, there's something called as the videos that I talked about again, machine learning recipes with Josh Gordon, TensorFlow workshop, ML glossaries, AI adventure, 7 steps of machine learning. But we are here for the course that I'll click here. This is the course, machine learning crash course with TensorFlow APIs. So once you click on this, it will redirect you to a course. 40 plus exercise, 25 lessons, 15 hours worth of course material, lectures from Google researchers, real world case studies, interactive visualizations of algorithms in action. Click on start course and it will talk about a wide variety of topic like introduction to ML, framing, descending into ML, reducing loss, first steps with TF, generalization, trying and test sets, validation, representation, and all the basic stuffs that you will need to know uh, to go forward with machine learning. Well, yeah, this was all about it. Thanks for joining. You can definitely tweet me if you have any questions, or if you have if you have a showcase that you would like to show me, or if you have built something and you would like me to have a look at it, you can tweet me at underscore Manoranjan P anytime on Twitter. Okay, thank you, folks. Have a good evening.